So we're talking about combinations of functions or composite functions. So the first thing we're going to look at is the domain and range. Remember, your x values are the domain, and they're the independent values because those are usually what we choose. And the y values will be our range, or the dependent values, because they depend on the value of x. Remember, you're going to use a parentheses when it is greater than or less than, or if it's an infinity or a negative infinity. But you'll use a bracket when it equals, or it's greater than or equal to, greater than, or less than or equal to. There are a few domain restrictions. Remember, you can't divide by 0 or take the square root of a negative number. You want to set the denominator equal to 0 and set underneath of the radical greater than or equal to 0, depending on what they are. So let's go look at these first. We'll look at our first example. So when we're looking at example 1, and we have g of x is equal to 3x plus 2 over x squared minus 2x minus 3. The first thing we're going to have to do is factor this. Now, I like to factor with the AC method. You can factor it any way that you want to. This one's kind of easy to see. What I can do, because you could factor this very quickly if you can see what the values are. If not, come over and make a t-chart. It's a times c trying to get you to b. So my a in this case is 1 in front of my x squared. So it's 1 times c, which is negative 3. And my b is negative 2. If you still don't know how to factor, then go back to a video I have on factoring so that you know how to do that. So I need numbers or factors of negative 3 that'll get me to negative 2. So the only numbers for a 3 are going to be a 1 times 3 will get you 3, but one of them has to be negative. I know that my b is negative, so I'm going to make the larger number negative. These two usually will match on sign. So 1 times negative 3 gets me negative 3. 1 plus a negative 3 will get me a negative 2, which is what we're looking for. So that means, because it's a 1 out front, I can go straight to parentheses. I will have x plus 1 times x minus 3. That's the factor of that. Now we're going to set each part equal to 0. So we're looking at x plus 1 equal to 0 and x minus 3 equal to 0. So if I move my 1 over, I will get x equal to negative 1. If I add the negative 3 over, remember you're going to have to do the opposite operation, so you'll get x equal to 3. So you don't have to show this step, so I'm showing you don't have to, but you've got to show this step and this step when you're showing your work on the exam. So what this really means is my x cannot be equal to negative 1 or 3, because if I plug those numbers in, I'm going to get 0 in the bottom and end up dividing by 0, which is a problem. So what I really need to do is figure out what other numbers it can be. So I'm going to find my domain. So the domain is going to always have a negative infinity and an infinity. And I'm going to take these two numbers and I'm going to put them in numerical order. And it will be everything but those two numbers. So negative infinity to negative 1, union with negative 1 to 3, union with 3 to infinity. You have to account for all of the spaces. So if you have two numbers, you're going to actually have 3 intervals. If you only have one number, you'll have 2 intervals. So let's look at another example. So we'll call this part A. Let's look at part B. We're still just looking at the domain. So to find the domain of this, we have the square root of 3x plus 12. Remember, you can't take the square root of a negative number, so that means this has to be positive. So I'm going to take my 3x plus 12 and make it greater than or equal to 0. It can be any other number greater, but it has to at least equal to 0, because I can take the square root of 0, but not anything below that. So I'm going to move my 12 over by subtracting it. And I get 3x is greater than or equal to negative 12. Divide both parts by 3, and I get x is greater than or equal to negative 4. So now I'll draw my number line again to figure out what does that domain in interval notation look like. And I have negative infinity, infinity, and that negative 4 is the only number I have. Well, it has to be greater than or equal to, so greater than goes to the right, so it's going to be greater than or equal to negative 4. So it's going to the right, and because it has an equal sign, it will get a bracket. Bring it on down, it'll be bracket negative 4, infinity, with a parenthesis. So let's look at one more function. Let's call this part C. What if we have f of x equal to x squared minus 7x? And I want to find the domain of this function. So again, let me write this. This is our domain that we were looking for. So in this case, if I'm looking for the domain, do I have any issues? Do I have a denominator? Nope, there's no denominator. Do I have a radical? Nope, there's no radical. So there's nothing I have to worry about. So my domain in this case will be negative infinity to infinity. So there's those two parts that you've got to worry about, dividing by 0 and taking the square root of a negative number. So the next thing we're going to talk about is the algebra of functions. So the algebra of functions, there are 4 of them. We're going to sum them, take the difference, the product, and the quotient. So if we're adding them, we're really just adding the 2 functions. If we're subtracting them, we're subtracting the 2 functions. If it's multiplication, we're going to multiply the 2 functions. If it is division, or a quotient, then we're taking the functions and dividing them by each other with regards to the bottom function cannot be equal to 0. All right, so let's look at example 2. So if we are given f of x is equal to 2x minus 1, and g of x equals x squared plus x minus 2. So the first part, we are going to find f plus g of x. Now remember, that's the same thing as taking f of x plus g of x. So we're going to take this function here and add that function there. I'm going to write it with parentheses just so you can see where each function is. So the parentheses don't mean anything. I'm just grouping them so you can see this is f of x and this is g of x. So now, because the parentheses don't matter in this case, there's no multiplication or anything, I'm just combining like terms. So I have a 1x squared part right there. So I have x squared. I have a 2x and a positive x. I'm combining like terms. That gets me 3x. And a negative 1 minus 2 would be minus 3. And this would be my answer. All right, let's look at the next question, or next part. So we'll look at part B. We are going to take f minus g of x. So that means we're taking f of x and we're going to subtract g of x. So I'm going to do the same process. So I have 2x minus 1 minus, this time I have to put the second part in parentheses because I have to subtract the entire thing. So I have to distribute the negative sign. So 2x minus 1 minus x squared, negative times positive x is negative x, negative times negative 2 is positive 2. Again, we're combining like terms. So I have 1 negative x squared. I have a 2x and a negative x. Well, 2 minus 1 would be 1. So plus x, and negative 1 plus 2 would be plus 1. And that would be my answer right there. The next one, part C, we're going to multiply our functions. So we have f of g, or f times g of x. So that's going to be f of x times g of x. So we're going to use the same 2 functions. So this time we have 2x minus 1 times x squared plus x minus 2. So I've got several parts here that I need to multiply. So I'm going to do it just like I normally would. I'm going to cover up the second part and just look at the first part. So 2x times x squared would get me 2x cubed. 2x times x will get me 2x squared. 2x times negative 2 would get me negative 4x. This time, instead of going all the way, I'm going to stack them because it'll make it easier to combine like terms. Negative 1 times x squared, I'm going to put it right here, negative x squared. Negative 1 times x would be negative x, and negative 1 times negative 2 would be positive 2. And I'm going to draw a line, and because there's 3 terms of each, it's easier if I stack them to add them. So we have 2x cubed plus x squared. Negative 4 and negative 1 would get me negative 5x plus 2. And that would be the final answer for this one. All right, so far we have just added, subtracted, and multiplied. We haven't had any fractions. We haven't had any square roots. So our domain for each of these is negative infinity to infinity. It's like the last example that we just did before this one. So again, negative infinity to infinity. There's no restrictions on our domain. There's no issues. Now when we get to the next part, part D, we are looking at f of g, or f divided by g of x, which is the same thing as f of x over g of x. So here we have 2x minus 1 over x squared plus x minus 2. This will not reduce. Because we have a 2x and we only have an x squared, we know that when we factor it, we will only get an x and an x. Now we will have to factor the denominator to find the domain. So we're going to take our x squared plus x minus 2. I'm just going to factor it, that it would be x plus 2 times x minus 1. We are going to set it equal to 0 because we need to figure out what causes us to divide by 0. So x plus 2 equals 0 and x minus 1 equals 0. Subtracting the 2 over, I get x equal to negative 2. Adding the 1, I get x equal to 1. Bringing up my number line, I have my negative infinity to infinity. I'm going to put my negative 2 and my 1, and I know it's going to be everything but those two numbers. So negative infinity to negative 2, union with negative 2 to 1, union with 1 to infinity. And this will be my domain. So this one had to worry about the denominator of the fraction that we created. So that's all you're doing with the algebra of functions. The next part we're going to look at is the composite of functions, or the composition of the function. So f with g is denoted by, actually it should be, I think, f of g. F, and it's a little o. It's not fog. It looks like fog, but it's not. And it's defined by the equation f of g of x. So f of g of x. I'm not sure why that says with. Must be a typo. Sorry about that. So f of g of x means that, so we've been doing lots of functions where we're plugging in like 2 and negative 2 and 0. What we're going to do here is plug in an entire function. So let's pull up a new paper. And we're looking at example 3. And we are looking at f of x is equal to 3x minus 4, whoops, no parenthesis, and g of x is equal to x squared minus 2x plus 6. Got ahead of myself with parentheses, sorry about that. So if we're looking at f of g of x, this is f of g of x. So what that means is it is equal to f of our function, x squared minus 2x plus 6. So we are going to plug this entire function in for x. So if you remember back in some of the other problems we've done, we plugged in an x plus h, we plugged in an x plus 3, not in this lesson, but in previous lessons in the class. So this time we're going to plug in this entire thing. So that means we're going to plug in this entire part wherever our x is. So that means we've got 3 times x squared minus 2x plus 6, and then we have a minus 4 sitting out there. So 3 times x squared, 3 times negative 2 is negative 6x. 3 times 6 would be 18 and a minus 4. Now we'll combine like terms, and we have 3x squared minus 6x. 18 minus 4 will get us 14. And that would be your answer right there. So they look complicated, but you're really just plugging in, instead of a 2, you're plugging in an x squared minus 2x plus 6. All right, let's go the other way. So what if we do g of f of x? So that means we have g of f of x. So that would mean we would have g at the f of x is 3x minus 4. So we're just plugging in this entire function right there. So in this case, because we have an x squared, we're going to have 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So everywhere there's an x, I plugged in 3x minus 4. So we need to multiply this out. Remember that 3x minus 4 is actually, our quantity squared is 3x minus 4 times 3x minus 4. So I'm going to come off to the side here and take 3x minus 4 times 3x minus 4. I will get 3x times 3x is 9x squared. 3x times negative 4 minus 12x. Negative 4 times 3x minus 12x. And negative 4 times negative 4 is positive 16. Combining those middle terms, I get 9x squared minus 24x plus 16. So replacing that in here, I would have 9x squared minus 24x plus 16. Negative 2 times 3x will get us negative 6x. Negative 2 times negative 4 is positive 8 plus 6. Combining like terms, I get 9x squared. I have negative 24x and minus 6x will be minus 30x. And 16 plus 8 would be 24. 24 plus 6 would be 30. And this would be the value. Now, if we're then asked to find g of f at 1, I'm going to take what I just found. So g of f at 1. I take this g of f of x and I just plug in a 1 for my x. So 9 times 1 squared minus 30 times 1 plus 30. Well, 1 squared is 1, so that'll get me 1 times 9 is 9. Negative 30 times 1 will be negative 30 plus 30. Well, the 30s will cancel, and my answer is just 9. All right. So that's what we kind of need to know for our values as far as finding our g of f and the f of g. Again, we don't have any fractions to worry about, and we don't have any radicals to worry about. So our domains would still be negative infinity to infinity. The only time we have to worry about that, again, is if we bring a fraction into the problem.